Okay, we want to welcome everyone to our first webinar of 2013. Um, you may have noticed a slight schedule change if you've looked at some previous schedules. We were going to be talking about packaging today, but we had to swap some things on our schedule due to some conflicts. So packaging will be in February and March. You can watch for these. If you want to look at the whole schedule for 2013, you can check it out in the magazine that just came out for January from the Brick Center, or you can look on our website, either one. We have a schedule there for the full year. We may have some changes as we go from month to month, but basically that'll be the outline we'll try to follow. Probably mention too, I know we're missing some people today. We're going on at the same time as the forum over in Greensboro that BIA sponsors, so some of our regular people over there, but we'll go forward without them, and they can always check out the recorded version when they have some time. So I want to welcome everybody that's here. First of all, a couple of announcements. Let me make some reminders here. We do have a short course coming up in March. That's March 4th through March 7th. If you've got anybody that may be interested in that, be sure to go ahead and sign them up, get in touch with the Brick Center. Let them know that we have somebody that you might want to attend that course. We plan on right now putting it on regardless of the size, but we would like to have at least 8 or 10 people to make it worthwhile. So if you do have anybody interested, be sure to go ahead and get in touch with them. Let me also mention that the spring meeting for the Brick Center, normally held in April, will be held in May this year, May 13th through the 15th. The center's going to try something different. This meeting is going to be in Salt Lake City in conjunction with the Structural Clay Products meeting, so it'll be a joint meeting out there, hopefully touring Interstate Brick and working with the folks in the Structural Clay Products industry on some of the programming. So you might also find some information on that if you want to look further on our website or in the magazine. There's also some information there on that also. Let me mention too that I did talk about the BIA forum in Greensboro that's going on today. John Sanders and Dennis Brosnan are both over there. And if you have not heard or not aware of it, Dennis will receive the BIA Lifetime Achievement Award over there today. They should be just finishing up the awards banquet. So you might give him his congratulations the next time you see him or talk to him. So we're proud of Dennis for that. And there will be some more information probably in the magazine issue coming up next about that award for him. So just a couple of things I wanted to mention there. Again, today we've changed the topic a little bit due to these conflicts in the schedule. We're going to be talking about color and fired color. Just a general review that'll hopefully include something of interest for everybody, regardless of where you work in the plant or what your job is. Many of you out there could do this. You're just as good and as well qualified as I am to do this, but I'm just going to run through some things on some different topics, which I'll show you in a minute, and just do a general review on color and bring out some things possibly linked to some projects we've been working on here lately. So again, I'll remind you questions and answers. If you've got one, just type it in, put it up there, and we'll try to answer it. And we will also have some questions and answers at the end of the program. So having said that, we're going to go ahead and get started, talk about color a little bit. And as I said, our topics today are going to be just the color of fired clay. We're going to talk about through the body color, individual clays or clay blends, a little bit more about measuring color, and then some color and appearance problems. We linked appearance in here with color because they're often associated with color problems in the wall, and we wanted to talk about a couple of things there. We will not be talking about any coatings. If you do look ahead on the schedule, you'll see that we have 2 sessions coming up on coatings later, and we've got some really qualified people that are going to be working on those seminars. So we will not talk about coatings today, just talking about clay colors, through the body colors, those kind of things in the seminar today. So now let me also mention here as I bring some slides up and talk about some things that affect color. You've probably seen some of these slides before. Probably the first 4 or 5 were used in the presentation on flashing. We presented them at that time and talked about what reducing conditions would do in terms of affecting color. So today we're going to take the same slides and go through them and now talk about oxidizing conditions and how these things affect color and look at it from a little different standpoint. So the main thing we want to remind you is people always tend to focus on the kills when we talk about color. That's the first thing that comes up, but obviously there are people situations, their materials, their equipment, their processes, all these things come into play. They all can affect color, And that's what we're going to talk about, but we're primarily going to talk about materials and processes. Materials and processes, those things, how they affect color, and what we can or cannot do about them. So with that background, let me again go through main factors influencing color, several slides here. First of all, the amount of iron oxide or its equivalent present. And there's a great study on this. Again, as I referenced there, Hugh Wilson in the 20s did a lot of work on this, even when I was back in graduate school working on a thesis. A lot of good work in his report. Just to remind you again that anytime we have more than about 2% iron oxide or equivalent, we can get a red color, 6 to 7%, really deep red color. I know most people, when you ask them about iron oxide, would guess 10, 15, 20%. It doesn't take that much. Greater than 2% for some standard red colors, 6 to 7% really deep red colors. So that's what we're going to be talking about today. How to handle that iron oxide, what happens to that iron oxide in the kill, and then some other factors that will come up later. So the amount of iron oxide is number one. The distribution of the iron oxide is key, or the iron, I should say. Is it in the sand fraction or the silt fraction as some kind of discrete compound? And here, when I say sand, I'm talking about plus 200 mesh. Silt would be minus 200 mesh plus 2 microns, so just the standard size definition that a lot of people go by. Is it there as a discrete compound, or is it in the clay crystals, which is the minus 2 micron fraction in that part of the structure? And if we take some materials, break them down, and then fire those various segments, we're going to see that most of the fired color is determined by the silt and clay fractions. You'll see that primarily by the clay fraction, but we will find some in the silt fraction. And it's hard to duplicate that in nature. It's hard to take an iron oxide and put it in a clay and get the same color that it naturally has, and that's why we can't get it down into that part, that size compound there. So it's so small. But just to know where it is naturally, and then right at the bottom, of course, I put the note there, know your materials. Where is it? What size is it? How does it occur? And that can be a key part of color and handling color as we talk about some color problems or situations. Now, this is kind of a busy slide, a lot of stuff on there, but just trying to put it in there to remind you, as I said, we're talking about both materials and processes. And some of us, obviously, if we think about shale body or a clay body or mixing shale and get clay together to produce a red body, there are several ways to do that. We can mix the clays together first and then process them, as it says here. That's what this slide is trying to tell you. Or we can take them and go directly in, put the materials together, and then grind them separately after they've been added. So there are two ways to do that. And it doesn't matter what kind of color we're trying to get here, some kind of flash color, pinks, browns, yellows, we mix. And then, of course, down on the bottom side of the graph, we've got kaolin and fire clay, the lighter burning materials, buff for the kaolin, white for the fire clay in this particular case. If we want to make a white or a lighter colored fraction, we can mix the two of these together and then add them to the blended red, or we can add them in individually. If we were using all four of these clays, we could mix them all four together and then grind them. Or we could do some processing with the individual materials. There's a lot of ways to do it as you go through this kind of little flow chart here. And the point I'm trying to make is, do I blend first or do I process first? How do I handle my materials? Well, that's up to your materials. But we have seen some color problems related to blending and processing, and the order in which it's done, and whether the materials are blended first and then ground, or are they ground first and then blended. In this particular case that we did a lot of work on here not too long ago, the purals were being ground first and then blended together, just mixed, and that wasn't working too good. We went back to blending them together and then grinding them, and it got a much better, more uniform body. So it's going to have to depend on your material and your process, particularly your material. So that's why this slide is here, just to remind you that that's something you need to think about. Maybe people don't consider that so much when they just put two materials together or three materials together. What order do I put them together? How do I blend them? At what point in the process do I mix them together? As you'll note, the note down here at the bottom says fired color comes from intrinsic clay. What's in the clay? The iron, just like we talked about. But it also comes from processing. How do we do it? Are we doing it the right way? And you need to find out what's the right way for your materials. We can help you with that, or if you probably have done some work, you may have a good idea. If you haven't done some work, then you should definitely look at it. But it's major in helping to control colors, particularly if you're making some lighter colors as far as what you're doing. All right, I just found this in our files here, older slide. I brought it out. That's Boral's lab down in Augusta. It says many plants have color panels showing the color produced by blends of clay. A lot of you have very similar files there for that. What I wanted to do was pull that out along with over here on the left. It says chemistry and particle size changed slightly with clay pit location. So there's a natural variation range in fired color. Most of us know that if we've been around the brick industry. But that's another support for stockpiling, another reason for stockpiling. If you don't do it, there are some, even in a very small pit, similar pit, top to bottom, inside to out, whatever the, part of the pit you're in, you can still get those variations in chemistry and particle size that can change the color. So we need to take care of that natural variation by stockpiling if at all possible. And then we need to look, as I said on the previous slide, back up here about the process of how do we blend those colors together if we're blending. How do we get the colors we want? What process do we use? And you can see all the work they've done or had done at that particular plant for mixing their clays together and trying to get some uniformity. So the variations in the pit, they're variations in processing. Most of you know this, but again, just pointing this out as we go to talk about a few key factors. Other factors influencing key fired color, obviously, composition of the clay mineral, what's in there. We need to test that. If you don't test that or are not able to test it, we can do that for you and find out exactly what's in there, the things that can influence color. Most of the time we're thinking about things like particle size, plasticity, this type of thing, but and what the final color is, but we need to look at what's in there that can influence the color, how much there is, how consistent it is, these type things. So composition of the clay mineral, what is it? Presence of calcium compounds like lime, the reason being the calcium has a major effect. Now if you're in an area that doesn't have much lime, then you don't have to worry as much about that. But if you do have calcium, it tends to bleach the red color, it tends to mute it some. You need to know that, how much is there, what form it's in, how consistent it is, those type things. And then, of course, impurities that contribute to the vitrified or glassy phase. These help lower the melting points. And, of course, most of us know that those are normally the alkalis. How much of those do we have? Again, are they consistent? What form are they in? These type things. So we do need to do a little work on this raw material other than just looking at particle size and clay mineral and things like that. Know what's in there, know how much is in there, and is it varying? And we can do that as far as helping you with that and looking at what's in there. Again, know your materials. Now, I just put up a good old chart here, which I'm sure all of you like to see, periodic chart, but just to show you the primary coloring elements in brick clay. Again, all of you know that it's iron, number one, but also manganese, natural chromium, and that's what I'm talking about here, is naturally occurring things that can play a major role. And then we were just talking about the alkalis over here. There's calcium, which can tend to bleach the color. Magnesium can do that to a little bit lower extent. And then we got sodium and potassium, which are these alkalis that particularly generate the lower temperature glasses that can be a factor. So again, where are they? How much is there? What form are they in? We need to know that. We need to keep working on that. Do some testing, know what you have and what the changes are. All right, other factors obviously influencing fired color. You know this, temperature determines what? Which iron compounds are present, how we affect the iron compounds. The amount of vitrification, we've again talked about that. How much glass do we get? At what temperature does that glass form? What's causing that glass formation? All these things come into play and can be a factor as far as color is concerned. And then, of course, we've mentioned before, and we mentioned during the seminar on reduction, that high temperatures can cause reduction of iron even if the conditions are oxidizing. Most of it probably don't get to those temperatures, but a few of it could be, if you get up in the 2250 or plus range, somewhere in there, you may start seeing some effects of just reduction caused by temperature. But we need to know what is going on as far as the kill, the reactions that are taking place, and what effects it's having on our particular material. So those main factors again, the composition of the kill atmosphere, we all know that. We talked about that during the reducing seminar here a few weeks back. Air-fuel ratios in the burners, obviously. Solid fuels, if we're using a solid fuel. Are we getting any flame impingement? And then, of course, flashing gases if we're introducing those on purpose. But the composition of the kill atmosphere obviously is a major factor. And we're not going to concentrate on that too much today because we're going to talk about more what happens under oxidizing conditions. But again, just to cover that. And then the total amount of this vitrification, even though I've already mentioned it several times, glass content, this is just to remind you again that it's determined by the raw materials, basically the impurities that are in there, but it can be additives that we're adding. Again, temperature, atmosphere can have an effect. And what we really see as far as color is the more glass, the darker the color. And that's what we want to pay attention to. If we're flashing, glass can help to stabilize those colors and prevent reoxidation. But again, we're thinking more of just standard colors here and these top two factors here. How they would affect us in operation throughout the plant on a daily basis. All right, firing in the kill forces reactions involving the iron. It's going to happen. It will happen. We just have to be able to control it. And under oxidizing conditions, mainly what we're talking about here today, what we want to do is produce ferric +3 iron oxide, Fe2O3, good red color. Under the reducing conditions, as we talked about before, we produce ferrous, iron oxide, FeO, or magnetite, which is a combination of the two down here. But we're mainly, again, talking about oxidizing and thinking about what we need to do here to produce those colors that we need to get the brighter, particularly, and the lighter colors. I mentioned this in passing here a while ago. Here's just a pictorial explanation about iron oxide. It says most clays darken as temperature is increased. We're pretty much aware of that. How do we know that? We can take a sample of your clay and particularly do a gradient bar, and it's very drastic on there what we see, much more than what you see out of a kiln, because we're producing a drastic, in our case, 200-degree range over a sample. And you can see how it changes, how it darkens, particularly some of the buff clays and the kaolin clays, how they change. When we say darken, they may go from, into lighter pinks to darker pinks, into buffs, into golden colored buffs, things like this, but they are darkening, so we need to be aware of that. Of course, in the traditional case of red iron oxide, we want hematite, and then, as I said, as we go up in temperature, we begin to get some Fe2O3 and Fe3O4, which can darken it, or if we go high enough, we'll get Fe3O4. So color darkening can be accomplished with temperature and flashing. We're aware of that in both cases. We just need to keep it in mind as we work from day to day, because sometimes we tend to forget that in some of our processes. All right, oxidizing conditions. I'll mention this again here, that at temperature and at the correct temperature with the right amount of time, we'll get clusters of Fe2O3, which is what we're looking for. That's what we want. And that previous slide that I had up there showed that we were trying to make Fe2O3. We'll get that if we take the right amount of time at the correct temperature, and we'll get those clusters of Fe2O3. And I've got a picture I'm going to show you here in a minute that's pretty interesting that goes along with this. These clusters reflect red light and give brick their characteristic color. Most of us are aware of that. We're also aware that variations in the kiln, whether it be top to bottom, side to side, can affect the time, which is usually the result that we're looking at of the reaction, or the temperature of the reaction, and can cause color range. So I put a note here right there. Each brick on the car needs the same amount of heat work, and we've used that term heat work several times in other presentations and in some of the magazine articles. We want to make sure that each sample is exposed to the same temperature for the same amount of time, and that's what heat work is. How do we do that? We measure that using pyrometric products and our thermocouple cards if we have a range. If we have to go in and work on it, we need to break it down. We need to find out what the problem is. Are we not getting to temperature, or are we getting to temperature and not staying there for a long amount of time or a long enough period of time? Particularly in the center of the car is usually where we see a problem. But those variations in the kiln, we need to remember how they can affect us, and remember that key word, heat work. Every brick needs to see the same thing. Whether you've got 4,000 on a car or 10,000 on a car or 15,000 on a car. Each brick needs to see that same heat work. Also, the shorter the firing range of the material, the tighter the controls have to be. Again, we can determine that on a gradient test, and we have a vast array of samples that have come out of gradient tests that we use in our short course to show people what a good firing range looks like, a bad firing range looks like, and some that you just have to completely avoid at all costs. So we've got samples of all those, but we need to do that for your material if you've never done it, and just look at that range and see what it looks like, how short it is or how long it is. And that gives you some leeway up here in how much you've got to work with the variations. But that's always something we need to test. It's a cheap test, something we can look at. And then again, at the bottom, I'm not going to bring it up a lot of detail, but just to mention reduction can occur, which changes some colors. So having said that, I was going to show you this picture, which we had here, and we used in some of our courses. This is a red brick under a microscope from down at the SEM lab back behind us back here. And it says over here, flashing changes the hematite. Again, that's what we're talking about over here. I won't mention that. What I'm going to mention particularly is down here, it says the white streaks are actually clusters of Fe2O3, which is hematite that absorbs all colors of light except red and make the red. When it says those streaks, we're talking about these white streaks right in this area, right in here, right there. You see all those white streaks? That's actually what gives a brick its color. You see the white streaks even among those larger particles. I thought this was pretty interesting to be able to see that. Why? Because it's got iron. Why is it white? It's because it's got iron in it under the microscope, and that reflects the light, and that's where it shows up as white. But it actually shows up when we look at it as red. That's where the red color comes from, these streaks. So it's not these particles, consistent round particles or anything like that. It's these streaks that give the brick the color. So you can see why we need to know what's in the brick, the individual materials, and particularly how it can affect the blend of materials if you don't blend them together properly, depending on whether you mix them first and grind, or then grind and then mix together. Sometimes you get a different pattern for these streaks in there, as they're called, or as we'll call them. So you can see how this could come to play to cause color variations. And this was a particular case that we did a lot of work on here that was having some problems in a plant here, one plant having some problems. And where we did a lot of work, we could actually see some streaks in there like this when we analyzed it. And we could see they weren't getting the materials mixed together very well. It was showing up not only as color variation, but we had some lamination problems because it didn't extrude very good. Had some uneven shrinkage problems because we had all these pockets of clay that weren't getting mixed up very good. So we made some recommendations there on how to blend this material, or these 2 or 3 materials in this particular case. And how to handle them and what to do to get a better mixture, and it helped solve some of the problems they were having, among them color problems. So again, you might just keep this in mind. Again, the white streaks, that's where the color is. That's Fe2O3, that's the way it ends up in a fired brick. So you can see not only how the mixing would affect it, but how they alkalize the amount of glass, the other impurities, the other constituents in that clay, how it could affect the size and shape of these various streaks as you see them here, as we'll call them, and can produce color ranges. So keep all that in mind just as you're thinking about things in the plant, problem in the plant as far as color. Now this is just a firing schedule, a typical little simple curve. I'm not going to go through it very much. It came out of an article really from Dr. Robinson. That he had wrote, and Dennis kind of simplified it. And it's basically showing a preheat over here, a soak cycle here, and the cooling cycle here. You notice there's some reference temperatures that tend to break this schedule up into these zones down here, 2, 3. So what I'm going to do is, that's there, and then the next slide goes with that. Here are all the zones over here that go with that previous slide, telling you what happens in each of the zones and how they affect color. So it's a good summary. You might want to, when you get some time after this is over, go back and look at the previous slide, look at this one, look at the zones in there, and then work back and forth with the information that goes with it here with the zones and what the temperatures are, and look at all the things that are going on and some descriptions that are in there about what's happening. And again, this is all just saying basically the same thing I've said so far, is that there are various things that can have an effect. It's talking about oxidizing conditions, clear burn, producing clusters of iron oxides. It's talking about flashing, height unaffected. Lime, produce lighter colors. That's that calcium effect I was telling you about here in these two. So there's some things going on. They're talking about reoxidation down in here that you need to read. So put these two together when you have a little time, read about them. Again, it's a summary. And if you want to get a whole discussion to go with it, there's the reference right down there at the bottom, Dennis Brosnan, Brickyard Road. He wrote this back in 2000. Again, it's some comments that have been added through various discussions with various people and added to Dr. Robinson's information that he had. So it's a good summary. So just take some time and read it. We obviously don't have time to go through it now, but you might want to look through that when you have a chance and pick up some more good information from that standpoint. This again is a variation of the chart that was there before, colors influenced by processing, firing in the kill. And you notice it says over here, most color reactions occur in the hottest zone of the kill. Well, that's what the previous chart's going to tell you if you look at it. Again, preheat, soak, and cooling. And this is just showing some key factors here. What is the soak temperature? Are we flashing? Time to form glass. Are we holding it at that temperature long enough to form glass? And again, that same statement, brick generally darken with increasing temperature. And I can throw out a good example on this, and just talking to someone here recently while you're just looking at that chart, talking about an old kill. And all of us back during the good old days here a few years back were running kills faster than they were designed for. And you know what that does. That puts a load on the kill, stresses the kill. We're trying to make good quality and yet go faster. We don't have that problem right now, but this particular company was in a situation of having a very old kill, trying to do some work with it. And they kept talking about, and I'm just going to throw out some numbers here just to give you an example, but possibly going from 18 cars to 20 cars. And they said, well, it's only a 2% increase, but we just can't handle it. The kill just, we get color problems, we get absorption problems, this type thing. So what happened is actually the time and temperature, as it shows on this kill here, the 20 car schedule, even though it was a 2% increase, was producing major variations. Particularly, they were still getting the temperature, but the time wasn't there. It was lagging, particularly in the maximum temperature in the middle of the car. So well, let's look back why. Let's look at some information. If you dug back into the records, this car was, or kill, excuse me, was built for an 18 car schedule. Now, obviously it was done by tonnage, but it converted at that particular time to an 18 car schedule. Well, that was an 18 car schedule, a certain car count of cord brick. So if you took the car schedule, multiply it times the number of brick and the weight of the brick, you came up with the tonnage going through the kill at that time. If you only looked at 18 to 20, that was about a 10% increase. But if you looked at the 20 car schedule, the car count now, which was higher, and the weight of the products, which were almost all solid brick now, which is a good 25%, right, if we go by the core size, their tonnages were way up. Their tonnages were more like 25 or 30% up. So even though 18 to 20 in their way of thinking was 10%, the tonnage through the kill was 25 to 30. And they were really seeing it particularly in this time factor down here that we have on the bottom of this graph. They could get the temperature, but they just weren't getting there and holding it long enough. So at that point, again, we all face that. If we've had it under good times, what do I do? Do I spend some money on the kill? Do I back off on the schedule? What do I do? How do I handle this? Do I open the load up? Do I cut back on the load size? What do I do to get the color more consistent? And we're talking about color, but in this particular case, it was a lot of different properties that were being influenced, compressive strength, absorptions, everything else. So we need to look at what the kill can do, what it's capable of, but we've got to stay on this curve in terms of these two key factors here. So everything in a brick that takes place is a kinetic reaction. If you look at the definition of kinetic, it means time and temperature dependent. So we've got to give it time at temperature to get the color we want and to produce those products that we're looking for. So we're also doing some really interesting burnout studies here now that I hope when we finish them up, that the people we're doing them for will either share them with you at the forum or let us share them with you at the forum. Looking at some burnout things, we've done some extensive STA, simultaneous thermal analysis on some materials. And then we've looked at some burnout situations with these materials, and color goes right along with that. That's the other factor we're that comes to play. We're not looking at color right now, but we're looking at burnout, but it's the same thing because it's time and temperature dependent. And it's really interesting, some of the things we've seen, and we hope we can share that with you down the road if we can get permission or either have some volunteers to do it from these plants for these materials we're working on. But main thing just to remember now is time and temperature. Major factor in terms of color and what colors we get. All right, I want to move on then and talk a little bit about measurement of color. I found this in the file. I just thought it was interesting. This is back in 2003, 4, 5, somewhere back in there. We had a Brick Center meeting in Pennsylvania and went over to Darlington Brick, which is no longer operating. General Shale, of course, owned it at that time, and happened to have this picture taken behind the color panel here as the plant was evaluating color. That was their sample for the runs they had made, and there was their standard sample right here. So how do we measure color? How do we evaluate color? So there's some of the old guys in there. There's Mitch Wells right there, Bob Bond. There's Garth. He's not that old, but he's still here. Mike Shipley right there. So various people. There's Kevin Ham right there. Just some different people around, but just to show you, they're behind the panel. They were looking at color, measuring color back there in the good old days. So just some basics about color measurement. And some of you are probably rolling your eyes saying, you know, don't give me this color stuff here. I don't know, want to know about color systems and measurement of colors, but this thing keeps coming up. We keep getting a lot of questions about it. When is the brick industry going to catch up? When are you going to do what these other industries do? So I'm going to include it in here and run through it again, just so as you're thinking about color and what can be done to measure color and how to control color, some things you might include possibly in your process. But just remember, color, white light is made of many colors, as it says there, and a prism, as it shows over here, will split that up into different colors so that we can visualize what color is. And as it says here in the little box, when white light strikes an object, some wavelengths are absorbed and some are reflected. And most of you know this. This is pretty basic. So what we're seeing is what's reflected. It says you collect them and process them, revealing the reflected color. So when we look at a red brick, that's what that red iron oxide in there is reflecting back to us. That's what we see. That's why it's important that we, as I said, showed you in that microscope slide, mix the colors together, get the right reflectance. That's why the glass affects it, because the glass obviously cuts down on the reflectance of it, and it affects it. And the little cartoon there says the color of an object is not contained within the object. The color is a result of the light which strikes the object and is reflected back by it. So that's what we've got to remember in dealing with color. And again, I know a lot of you, as I'm saying here, are saying, you know, okay, that's great. What do I do with that? Well, I just want to run through again all the things that affect color, as you can think about it. These are the same brick, same panel, just taken under different conditions with the camera basically set the same way. This one's inside under incandescent light. This is outside in indirect light in the shade. This one's outside in the bright sunlight. And you can just see even the wood on the frame of the panel, you can see how it's changing here. But you can also see how the brick are changing. So we've got to remember that all brick are not the same under different color sources of light, different colors produced by the sources of light, I should say. So we need to keep that in mind, just as we need to keep in mind the previous slide about the reflectance here, why we see colors, what affects colors, and again, I want to mention some other things that affect colors and then summarize this real quick and move on to some other areas. But again, we keep getting asked about this and measuring color and catching up with the other industries. So other things that affect color obviously is the observer, our sensitivity of our eyes to color, our age as we get older. Us older guys don't see color as quite as clear as other people do. The size of the object being viewed, larger objects again brighter and more vivid. The background can have an effect. Contrast there, of course, the direction, the angle that we're looking at it from can have an effect. So again, all the color meters and everything are meant to minimize these factors so that we see the same color every time with a color meter. Now, not all of us have a color meter. There are some plants that use a color meter, but again, want to emphasize this because, again, not only talking about brick color, but some of the products you use, you were seeing more and more information being reported on those products with color data, color information. So we still need to keep this in mind, even though it can be a pain sometimes to think about color and how we might use it. I'm just going to run through these characteristics of fired color a little bit. talk about the hue, value, and saturation. Again, you don't have to know this. It's all somewhere you can find it if you need it. But hue is basically the big word for color. It says down here tint, but that just basically is it red, yellow, blue, or green. Going around the circle here, which color is it? The basic colors, the tint, or the hues, you'll have it called in the textbooks. So one of the characteristics is hue. One of the characteristics is called lightness or value, as we had on the previous chart. This is the brightness. Is it a lighter color? If it's green, is it light green or is it dark green? Which range? Lightness going from light to dark. Major importance as we distinguish colors, particularly going from lighter to darker. Again, I'll show you a chart in a minute here, help you a little bit with this. And finally, the last thing on that chart was chroma, which is the quality we distinguish the intensity of the color. And in most of these color systems, that's related back to gray. So as you can see here, I'll go down here, pure gray coming across here to get more blue. So this is pure blue. So how does it relate? How does that particular color relate back to gray? Is the chroma, the quality called there, the intensity of the color. So that's all put together in the system, and this is what I was trying to get around to. The other stuff is not that important, but again, these numbers are, and more people are looking at them, asking about this LAB system, talking about it. L being the lightness, 0 at black, 100 to white on the axis, A on the red to green axis, plus to minus, and B on the yellow to blue, plus to minus. And again, what does all that look like? This is probably the key thing here. As I say, if you can always find any point in this three-dimensional color scheme here by defining 3 locations for that color. Light to dark, down here is black at 0, up here is white, which is 100. Again, here's negative to positive on this axis, negative to positive on this axis. So any point in here, we put a point there, we can classify it in terms of those 3 colors and come up with an LAB number for it. And again, you're going to see that more and more, and you're going to hear about that more and more. And you've probably heard about it enough, as I said, but I just wanted to mention it in there because it seems to be coming back in popularity, seems to be expanding in use. Obviously not used that much in the brick industry. There are some plants that use it. There's an old slide from our files. That's the Borgle plant in Augusta, Georgia, using their meter to check color, and you can see him reading it there and filing that away for inventory. A lot of plants do that, and you may in the future have to start thinking about this some more, how I can do this, providing this information to people, because they're going to keep asking about it and asking for it. They're very intent with this green movement on matching things exactly and doing things with a minimal amount of work. So again, you may hear for it. And just something of interest, I had a short course there, back in 2011, I think it was, one of the first ones that had a long time, and I happened to show this slide in there, and the guy that was right there said, "Hey, that's me in that slide." So he came up to take a refresher course from the short course. He was back in Borgle in the good old days, but he happened to come up and talk to us some about what they're doing now. So again, those are just some quick slides on color measurement, color system, things like that, just to keep you familiar with it. Again, you're going to hear about it and see about it and think about how it affects your process, and is there any way I can use it in my process. Now, color problems, other items that affect appearance. As I say, we kind of lump these in here because these things that affect appearance, we get involved in some situations with those, sometimes have to do some testing. So usually it's aesthetic, it's the way it affects the job, so that's why we put it in with color, because it's usually not a durability or a problem like that, but things that affect color. I'm just going to mention probably the first 4 here quickly, and then talk a little bit more about some of these others as we go down through here. Of course, poor blend of color. We usually think that's the mason's job to take care of that, and he should do that for us. We tell him how to do it on the packages, but we need to do the best job we can. That's why it's on here for whatever we can do in the plant, whether it be the way the brick are blended when they're set, if they're automatically set particularly, or how they're unloaded, if they're unloaded automatically. What are we doing in terms of color range of the kill? Are we working off different cards, trying to blend colors? Are we doing everything back in the grinding, blending as we talked about earlier? Are we testing the raw materials? Are we stockpiling? Are we doing everything in the plant we can do to get a consistent color so that we don't have to depend on the mason? So That's why that's there. Again, just as a reminder, efflorescence, we've had a webinar on efflorescence. We're going to be talking more about efflorescence and lime runs. We lump those together. So we're not going to spend a lot of time there, but that again is one of those problems that comes up that gets thrown in with aesthetics. Vanadium stains, very similar. Some of you have that problem, some of you don't have that problem. So again, we're not going to spend a lot of time about that. Chippage, we're not going to spend a lot of time talking about chippage either. It's pretty well defined in the ASTM standards what chips are, what's acceptable, what's not acceptable. Mentioned it there because we have done some work on chippage here recently, looking at things like particle size, maybe extrusion, the extrusion process, stresses in the body. And this is another one of these things that maybe down the road here we can get a talk at the forum and talk about a little bit. But I know some work I first did with chippage back in the 70s or 80s. We found some migration of fines in the extrusion, which we thought were contributing to chippage. So these are the kind of things we're looking at now. How does particle size affect chippage? How do additives affect chippage? Is there something you can do in extrusion? How do you get rid of those stresses that may contribute to chippage from the extrusion process so you can handle the brick easier? So that's why that's in there. Again, get down here, I'm going to talk about face cracks, and the rest of the items here, the remainder of the items, there's a slide for them. So what I'm going to do is go forward with that and look at face cracks. Again, this is a firing defect, obviously. For those of you that are not familiar with a face crack, that's what it looks like. Usually coming from the preheat part of the kill, usually due to some kind of shock in the preheat part of the kill. Normally somewhere around the first burners in the preheat where the clay is breaking down. You go in through the quartz inversion, all these kind of things in the preheat. This is the kind of crack that shows up. I mentioned it here. Why is it in here? Because it's an appearance problem normally. You say, well, how does this get in here with color? Well, there's something in ASTM about it. It covers cracks. It says if you look at them for 15 feet for one type or 20 feet from another, then it's not a problem if you can't see it from those distances. But it says if cracks are not visible from the specified distance, they're considered not significant and they do not detract from the serviceability of the wall. And that key word right there probably is serviceability. Aesthetically, they don't look very good, and that's why they're lumped in here with color. So we get a lot of questions about this crack, this type crack. I know the brick's okay, I know it's durable, but I don't like it. What caused it? What I do about it? Well, there's not much you can do about it. Once it's in the wall, you can cull it out before it's put in the wall. But as far as durability, it's not going to be affected. These are normally very fine hairline cracks. Most of the tests we've run show that they don't affect durability. Some of you may have had experience on your own with these type cracks, but again, that's usually the question we're asking: does it affect durability, and what can I do about it from the standpoint of how it looks? And not much can be done about it, about how it looks. Hopefully you can learn if you have them and go back to the kiln and make the changes that can get rid of these. What do? Well, you may have to adjust the schedule, you may have to adjust the material, you may have to slow the kiln down if you have these, but normally they're more likely to occur in larger products than smaller products. But find out what's causing them and get rid of them is about the best thing in the plant before they ever get out into the job. But again, it's an aesthetic problem out there. I think have a letter on file that says this is not a durability problem if you have it in products. So again, I want to mention that. Lime pops, some of you have this as a problem again, some of you don't. And this is just an explanation right here for a lime pop over here on the right. I'm not going to go through that. You know what most of you know, that it's these granules of lime like that right there that are left in the body. They're not ground up. If we can't get the lime out by mining, selective mining, or we can't grind it fine enough and those are left in there, then they can come out of the kiln and react with the moisture in the air and form this lime pop, which tries to expand and causes the pop. Most of you know that. Again, why is it in here? Because it's an aesthetic problem. And a brick note here, brick staining can be used so pops are not visible from a viewing distance of 15 to 20 feet. And this is probably the key point again why I have it here. Lime pops do not generally result in weakening of the wall. The brick are not going to be less durable. Once the particle there absorbs water and expands, that's it. And it's just going to be an aesthetic problem. You can stain them. Again, it can be classified as a color problem, an aesthetic problem, whatever. So that's why we put it in there. And I think I have an example here. This is some pictures we took from a job we were looking at. Here's only 8 feet away here. You can barely see that line pop there. That's what it looks like up close. And of course, that's where they tend to look at them if they have them up close like that. You can't stain them to get rid of them, so you can't even see them up close, and particularly can't see them from the required distance. But again, the key factor right there that put this in here to include this, line pops are a surface defect, not an interior defect. So normally the brick are going to be okay, and I think we also have a letter on file that Dennis wrote to cover those situations that can be provided if that is a problem. Again, how do you get rid of it? You either do selective mining or you grind it finer. Those are about the only two things you can do to really take care of that situation. Okay, pyrite pops, those are also on the list for the same reason, very similar again to a lime pop, except these are iron, analogous to lime pops, exception that iron-rich phases are involved in this surface defect. Again, keyword surface defect. Same thing basically happening, except it's not a moisture expansion. It's more of a kill reaction with the iron that causes the pop. It doesn't occur that often unless you've got the raw materials and then you've got the right amount and the right size and this type thing. Pyrite, that's usually where it comes from. And these are usually seen in the inventory brick on the yard. They're already there when they come out of the kiln normally, and they're there, so you know they're going to be there. You may have to resort to the same standards as far as lime pops to say I can't see them from this distance. They're okay, or you may have to stain them to make it not a problem as far as the aesthetics is concerned. Again, to get the customer happy. But again, we stuck them in there for that same reason. And I might mention to you again, it's not referenced down here, but Mike Vickers, before he passed away, wrote a series of articles on pyrite pops. They're in our magazine. You can go on our website. Just put in the keyword pyrite or something related to that. It'll pull it up. And it's about a 3-part article that starts from the beginning of the process with the raw material through to the fired product. And you can read about pyrite pops in great detail there and go through that from what Mike wrote about it. Okay, black coring. Just mention that again. Now, hopefully you don't have anything that looks this bad. It's a kind of a bad example, but we've seen a lot worse. But this is, of course, a heart caused by carbon left in there, or carbon causing the problem. It's affecting the iron, causing the black hearts. The main thing there, when we list it again, black coring alone is not a defect in clay brick, and standards do not limit the extent of black coring. Now, we have had brick come in here from jobs where architects have seen just brick that had coring maybe the size of a dime or something in it, just very small. Very suspicious that that was a problem, that something was going on. What is it? How do I handle that? So again, that's why it's in here. Again, it's not a color problem, but it generally can be an aesthetic problem. It's something they don't like because they can see it. They question what it is. And it says, many authorities believe that black coring accompanied by bloating, as shown on the left, can suggest potential durability problems in the wall. The ASTM standards for clay brick roofing tile allow black coring without bloating dimensional changes. And that's probably the key statement right there. Put that arrow there and leave that for a minute. The ASTM standards for clay roofing tile allow black coring without bloating dimensional change. So now obviously this brick here has a dimensional change. It's bloated enough that it's no longer the correct size. But a lot of the tile that go out that do have these coring problems in it, because some of them are fired so fast, 45 minutes, 30 minutes, not unusual for firing red tile. And you can't get all that carbon out in that amount of time unless you do put some additives in there, and those usually start affecting absorptions, and you don't want to do that in tile. So that's why it's in that standard. It doesn't hurt it as long as the dimensions don't change. So black coring alone, again, going back up here, is not a defect in clay brick, and standards do not limit the extent of black coring. So we have some letters, I think, on file for that also that state the same thing that this box over here is stating. So again, an aesthetic problem. It doesn't show up in the wall normally. Where we have found it on job sites and been brought in to look with people is when architects see brick that are cut, and they see these surfaces in here, they immediately question, what is that? Is that durability? Is it going to last? Am I going to have a problem down the road? So obviously, again, the cure is to get rid of it. That's something we're working on, as I told you a while ago, that we've been doing on a couple of projects. that I hope we can maybe by the forum share some information with you that's very, very interesting about coring and how to get rid of coring if it's a problem and what the alternatives are. So we'll keep working on that, but just so coring, you keep that in mind that that can be a situation. Iron spots here, I just mentioned it, the things that cause iron spots. If you have them in your clay, again, they're kind of like pyrite pops. How do you get rid of them? Well, you try to mine selectively if they're evenly dispersed. You try to grind them so they're not a problem. Natural iron spots, as it says, are caused by mineral fragments entrained in the brick clay. Fragments are usually black in color because of their iron content. They're very iron rich. Even firing them under oxidizing conditions, they're not going to turn red. And they contrast to the background. And then there are, of course, some synthetic iron spots where people are using them purposely. We have some on the building here using either iron oxide or manganese oxide additions. But we're mainly talking about natural iron spots here, which are normally these materials right here. And if you can't get rid of them and they show up in the wall, then it's the same situation as a pyrite pop or a lime pop. Of course, the ultimate solution is just raise the price and sell the brick and use it as a unique characteristic. But if it's a problem, if there's a complaint, the same thing applies as far as what distance you can look at it. You can always stain it or do whatever is necessary to make it so that it's visually not a problem and an aesthetic problem. But we did just want to mention those if they're in there. We've done some work on that and been involved in some of those situations also. Metal staining, I'll just mention because we do run into this occasionally. And of course, metal staining is the bleed or run from soluble metals over the face of the brick during wetting and drying periods. And it's a form of efflorescence, but it's really much harder to get off and looks a lot worse than regular efflorescence does. These are usually brown or black stains in rough brick. It can be additives, improper cleaning, or from the brick itself. You can get some things out of refractory mortars on a chimney you don't see in other places, or green stains if you've got some of these other salts present. The main thing I want to mention here is the very last statement again. On these situations where we've got into metal staining, again, a color problem, the center provides chemical analysis to help find out what it is, and that refers back up to number 2 up here. These stains are the additives from the clay itself. Is it improper cleaning? Can we find some residual acid or something? Is it coming out of the brick itself? What's the cause? So we need to do the analysis down here, figure that out, and hopefully give you a clue there as far as what to do to solve the problem. So again, it's improving a color problem, improving a color complaint, because that's usually where these metal staining situations end up. So that's why that's in there. And one final thing I'm going to mention here, the final thing on that list, is staining, recoloring, whatever you want to call it. Get a lot of questions about this. Brick staining is the application of permanent inorganic pigments or mineral particles on brick in the wall to correct color problems. The stain is absorbed in the surface pores of the brick, providing permanent adhesion to the brick. Mortar can be stained as well. And most manufacturers, it says, warrant staining for the period the house is occupied by the original owner, or some of the discussions are for certain years, certain number of years, a period of time, or whatever. It varies by company. That's pretty much up to the manufacturer and the people doing the staining. But just mentioning here that these are questions that come up, and that is, number one, how permanent is it? What does that word permanent mean? We've tried to address that with some letters and some information on that. Probably will continue to do too if it's something you have to do. We usually get asked to write a statement. How permanent is it? How does it work? Is it going to come off? Is it going to cause additional staining, just additional run problems, something like this? But how long is it going to last, and then what's this manufacturer going to do about it? So again, to point that out is something we run across as far as what we would classify as a color problem. Now, I've been through this in about 90 miles an hour. I know, and I'm sure there's some questions or comments, and there was a lot more information I could have included. I had to cut it down, though, to get it within our hour time frame, and we've just about used that already. But what I'd like to know here is any questions, any comments on anything that's been said, or maybe do you have any comments that you can share with us, or anything you can share with us about some experience that you may have had with any of these situations? Color problems, anything as far as color situations in the kiln that anybody can share with us. And while I'm waiting to see if you do, go ahead and just type in anything. Thank you, Stu. Appreciate that. But anything else anybody has, I'm going to talk a little bit and keep watching the screen here to see if there are any questions or comments, because we will be addressing, hopefully, at the forum, some things that we've been doing some work on as far as STA analysis of materials, what STA analysis tells us that we thought we knew and maybe we didn't know as much about. Particle size, we've looked at some things there, some interesting things about the effect of particle size that we've really seen. And then if it gets down to we've got to solve some of these problems in the kill, and that's the only way we can do it, we have come up with some information that will probably shock some of you about the amount of time required to do some of the things we want to do with brick and to make a brick out of clay and what's required. So we will be trying to share some of that by the forum. And if anybody again has any comments or questions, I'll be glad to take them at this time. Also, while I'm waiting, let me remind you, February 27th, that will be the first webinar coming up on packaging, and then March will be the second one. We're going to talk about packaging materials, of course, corner edge protection, things like that, strap, quality control of packages, things like how do I make the best package, how do I test my packages. And we're going to have a couple of our outside vendors helping us with that, so we're looking forward to working on that in both February and March. So, okay, I still don't see any questions, so hearing no questions or comments, we appreciate you being here. Look forward to seeing you again in February, and hope everything was worthwhile and everybody got something out of this webinar on color. So thank you for signing in. See you in February.